life examples of what waves look like, and also defined wave and the terminologies used in describing wave. We also made mathematical representations of some of the parameters which we later used to solve some questions. Okay, before we move to what we're doing today, last week I gave you guys some of assignments, and what are they? Assignment one. Okay, you're not in previous class, don't stand up. You're in the previous class. Stand up, stand up, stand up, stand up, stand up. Stand up. You are looking at me. Me too, I'm looking at you. Stand up. Ajomorawa. Oh, that's your. Just come, sit down. Stand up. Are you not in the previous class? Stand up, stand up. Stand up. If you answer questions, sit down. Yes, that's it. If you cannot answer the question, you remain standing till we are done with the class. Or till when the Holy Spirit touch my heart and say, okay, let your child sit down. All right. Madam at the back. Yes, you are. See, it's just 6 or 7 days in travel.
Where you think the direction they travel?
Yes, build them out, Thank you. Please sit. You said one now. You cannot sit down without bomb. That's it. What's going on there? All right. You. I said, give me two characteristics of electromagnetic waves. Yes, two characteristics of electromagnetic waves. Two characteristics of electromagnetic behave. How will you know that this thing is a magnetic wave? Really mad.
They travel through the material and they require vacuum.
Was I the one that told you that one? No. Thank you. Now you can sit. You can't sit down without bomb. That's the rule. You can't sit down without bomb. Now, based on the assignment I gave you, no, don't let me even go there. Let me still look for one or two. Speed of light.
Is it delivered?
Yes.
3.0 times 30. Yeah. Shut up.
You now, what's the relationship between wave velocity, wave frequency, and wavelength?
V.
Or wave speed? Yes, wave speed, wave frequency, and wavelength. Thank you. You can sit down. Yes. Now, 3 men standing. Oh. 2.5, 2.5. Okay. Rejoice. Down to you. Last week I asked you guys to check out submultiples and multiples in physics. Yes or yes?
This is the assignment.
The classwork. Yes or yes?
Yes.
Which of the yes? Is it the first yes or the second yes?
First
So,
yes.
the first yes. Okay, that means I'm correct.
Let me open my book and tell you.
Okay, give me, don't open give me 3 or 4. Give me 4, and their standard forms. Can yes, mega. What's the standard form?
1,000. Then mega.
Yeah, you did not get that one. No? Yes, now what's that? You did not give me the standard form now. You know, more of these questions now will be coming in. All these multiples and submultiples in physics, we're carrying it. So how will you? Thank you. No, open your book. Go and bail out. Did you do the assignment? Mimi. Did you do the assignment? Thank you. Close your book. Thank you. Don't tell me how to do it. This is how I want to do it. Okay, what is wave velocity? Define. Yes. Define wave velocity now. You should share your question. At what angle does transverse wave travel? At what angle does longitudinal wave travel?
Sir, you said they will share their questions.
I've given you people your questions.
It's my own question is that
what angle does longitudinal wave travel? You define wave velocity or wave speed. At what angle does transverse wave travel? Chikena. Yes, the remaining people that are not standing. No, you can't answer another person's question. For you guys that are just joining, welcome to today's episode. We have one outstanding question, which is calculation. Can someone take the questions for me? What are the parameters? So you guys can join from here, and you collect notes. You collect notes to what? To write based on what we have done last week. Okay. What's the question? What are the parameters?
Number of observations.
Solution to assignment. The first question. What's the first question?
The distance between. Okay.
The first assignment question. I gave you 2 calculations.
Okay.
Yes. What's the first calculation?
The distance between 2 successive currents.
Distance between 2 successive currents.
Of a wavelength is 1 meter.
Okay. What was the approach I gave you guys last week? If you see this kind of question, how do you approach it? Thank you. You bring out the diagram between 2 successive crests. Then what other parameter do we have?
We have time. Number of oscillations.
Number of oscillation is what?
2 complete vertical oscillations.
2 complete
vertical
oscillation. That means this diagram is correct. So it is just correct.
Yes.
Okay, 2 complete oscillations. Yes.
In 1 second.
In 1 second. 2 complete oscillation in 1 second. So the time is what?
Time is 1 second.
Then calculate what?
The speed of the wave.
So now these are the parameters given. So from this one we can deduce our what? We can deduce that our frequency is what? Number of oscillation over time. Is that not it? Which is what? 2/1, which is 2x. Abi? Yes, sir. Then from what that lady gave us, V is equals to what? F lambda, Abi. So we can say F is what? 2 times 1, which is 2 meter per second. As simple as that. This kind of question, if you see it in JAMB, you don't need to calculate anything. You just look at it and say the answer. And B did not still get it. You don't need to solve this kind of question. This kind of question is bonus question in JAMB. You just look at it and pick the answer. No need of calculation. No matter how big the English is, just look at, just use your eyes, bring out the parameters, multiply, and give them the answer. So you have to work with what? Time. For your CBE, you have to work with time. Computer-based, you work with time. Should we allow them to sit? No, Harry. Okay.
Just listen to something I thought.
No, it's two of them. What did you say? They should not sit down, Harry. Okay, majority carries the vote. Yeah, no, after you have opened your book, it's not me. Alright, the second calculation question. Yes. You drew one thing like this. What's that one thing? Number 2.
Vacation.
See, it's me that gave this question. Which kind of question is this? Lord of Zachariah. I was the one who. Alright. This is 2.5. So I gave you something like this. 1, 2. So you have 0 here. You have this to be 0.01. Then this to be 0.02. And this is the first crest. This is 0.1, 0.2, 0.3, 0.4, and 0.5. Are we together? This is crest, trough, crest. So using this waveform above, determine 1, the amplitude. What is the amplitude from this question?
0.02.
Thank you. 0.02 what? Thank you. Number 2. What is the what? Period. Period is what? Capital T. So now how do you go about this? Period. You know that period is same as saying the time over the number of oscillation. Abi, inverse of frequency. Is that it or not? Please, are we together? Hello. Hope I'm not speaking Japanese. Hope I'm not speaking Japanese. Alright. This one is same thing as inverse of what? Of frequency. And once you see this graph plotted like this, it is usually the displacement against the time. What do I call it? Displacement against the time. So the displacement is the what? Is the amplitude. Then the time run along this axis. Remember I told you we have 2 axes, Abi? The y and the what? And the x, Abi? So the x-axis is usually in seconds. And the y in what? Meter or centimeter. Are we together? Because after this we'll be approaching wave equation. So you should know that this waveform is usually in the y and the what? X axis, which is what? Displacement against time. Are we together? Remember when we talked about the wave speed or wave velocity? Wave velocity or wave speed? Wave speed, I mean. And I said the same thing as what? The same thing as wave velocity, because they are all against what? Time. It is meter against seconds. Do you get it? So that's why it is what? Displacement against time. If you see the graph like this, it's usually what? Against time. All the ones we have been drawing since last week is what? Displacement against time. So I gave you this assignment to prepare you for the next class, and if you guys have done it, you would have understood what I want to introduce you to today. But most of you did not do it. How many of you did it? You did you do it? You did it?
I did it, but I used number 1.
All right, that's okay. Now what we're going to get from here is that one complete oscillation takes 8 seconds. One complete oscillation takes how many seconds? 0.2 now, Abby. So the time is what? The time is 0.2 seconds, because from this place to this place is another complete oscillation, which is what? Also 0.2 seconds. Then the number of oscillation from this place to this place is what? Is 1, Abby. So we have what? 0.2 seconds as the period. Yes, ma'am.
Why is it like the period of 1 finding 1?
If we use 2, we will still get the same thing. We have 2 complete wavelengths here, Abby, and that is what? 0.4, Abby. 0.4 divided by 2, we still have 0.2 seconds. This is, so the period is what? 0.2 seconds. Yeah, you guys sit down. Like, come again next week. Without reading, we still do the same thing. Yes, you have not answered question. No. Don't think you escape. All right, what's the third question? Frequency of the above. The frequency will be inverse of this, Abby.
Yes.
Which is 1 over 0.2, which is 1 over 2 over 10, which is 10 over 2, which is what? 5x. Is there any magic? This is simple. Is there any magic? Any question? So, who got this? Take your book, take your book. Who got this? Told you last class that you are not part of this class. You are an extension. Yes. So, who got this? Who got this? Nobody. All right, put it down. Put it down. So I'll introduce you to today's topic. Any question? For those of you that are just joining, is there any question? Hope you guys watched last class from YouTube. Nobody did. You can visit the last class on YouTube. It's right there. Alright, so today we'll be talking about, can I rub this off?
Yes.
Alright, today we'll be talking about characteristics of waves. Characteristics of waves, then the wave equation. So there are 5 major characteristics of waves that we're going to be discussing. The first is reflection. Reflection 2, refraction. Refraction 3, diffraction. 4, interference. And 5, polarization. I think this is it. Reflection, refraction, diffraction, interference, or superposition. Superposition. So these are what we'll be looking at. Then after this, we'll go back to the forms in which transverse transverse waves exist. What are the forms? I gave you last week. Yes? Yes. I said there are 2 forms in which they exist. Transverse wave. I said there are 2 forms in which they exist. For those of you watching, you can subscribe, like, and share. Thank you. So, I said they exist in 2 forms. Yes, what are they? Transverse waves. Those of you that were in class last week, stand up, stand up, stand up, stand up now. Please stand up, stand up. Thank you. Don't even say anything. You are covering your face. Oh, sorry. By next week, if you don't read, you'll be in their position, you'll be in their shoes. And you too. Same goes to you too. Yes. Oh yeah. I said transverse wave exists in two forms, which are, I give you Jackson kick. Oh, really? That's what me I taught you. Those are examples. That's not what I asked you. I don't know. Those are examples. Oh, you are not in the class. Your dad called, really? Oh, it's your own dad that called. See, you know write it. Interesting. We'll all stand up. Welcome to the committee of stand. And the live class does not mean you. Yeah, that's for you. That's for you. Me, I gave you those at form. I said hello. I said crest and trough are the two distinct regions. In transverse wave. While in longitudinal wave, we have two distinct regions, which are refraction and compression. Now, I gave you forms in which transverse wave can exist. Me? Oh, is it I did not write it down? I gave you. If I should say it, I'll remove my butter for you. Stop. Just shut up. Shut up. Don't say anything. I said standing and what? Standing or stationary waves. Oh, now you can talk. Progressive or traveling. Oh, you wrote it, but you don't know where it is.
Okay, see. I do not see now. It's not a form. Oh. Nature.
Yeah, nature at the form. What's the difference? What's the difference between nature and form? What's the difference between nature and form? I said two nature in which transverse wave exists. Two forms, and I asked now two forms in which transverse wave exists. She said I said nature last week. Then today I asked form. So what's the difference? What's the difference? Tell me. Between nature and form. Last week I told you nature. Today I told you form. Oh, the difference is change in English. Oh, really? So I must ask you nature again. Sit. All right, reflection. Please write reflection. 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 How many of you know reflection? Who can explain reflection to me? The speed in which light travels through Earth. Talk now. Yes. See, who is this boy? Where is he from? Don't wonder. I never know him. Yes, you want to... Which kind of wave? Yes, now it's correct. Bouncing back of waves. Which kind of waves? That reflection is mostly attributed to one specific type of waves. Light. So, bounce of light rays from a shiny surface. From a shiny surface. That is mostly the definition you get as reflection. Okay, right. This is the change in direction. This is the change in direction. This is the change in direction at which waves travel. This is the change in direction at which wave travels without a change in medium of the wave. Without a change in the medium of the wave. This is the change in direction. This is the change in direction at which wave travels without a change in the medium of the wave. Full stop. During reflection, full stop. Full stop. During reflection, the wavelength, frequency, and wave speed of the incident wave remain unchanged. Only the direction is changed. So this is what I'm trying to explain. Assuming you have the light source here, then you have a shiny surface. If the rays coming from this light source touches the surface here and comes like this, there's one halfing here, standing here. So now this is the light source. This one that is falling on the surface is the what? Is the incident. This is the what? Incident wave. Why this one is the what? Is the reflected one. Is the reflected wave. Why this one is the reflected wave. So now what they are trying to tell us is that all other parameters of this incident wave is constant. It is not what? Changed. Only the direction is what? Changed. Do you get that now? Only the direction is changed. Is there any question? Any question? Hello? Any question? All right. Okay. I want to ask a question. Which of the following wave parameters will change during reflection? Which of the following wave parameters will change during reflection? 1. Amplitude. 2. Speed. 3. Frequency. 4. Direction. 5. Wavelength. Direction. So sometimes the questions can come like that. All right. The next one, refraction. Refraction. This is the change in direction. Refraction. This is the change in the direction at which waves travel. This is the change in the direction at which wave travels. As a result of the change in the medium, as a result of change in the medium of the wave. As a result of change in the medium of the wave. Full stop. During refraction, during refraction, during refraction, during refraction, the frequency of the incident wave, during refraction, the frequency of the incident wave remains unchanged. Remains unchanged, but the wavelength, but the wavelength, the wavelength, the wavelength and speed, the wavelength and speed, the wavelength and speed will change. Wavelength and speed will change. Please underline for reflection, underline frequency, wavelength, speed, that definition. In that definition of reflection, underline frequency. When I say during reflection, the frequency, underline frequency, wavelength, then speed. Then underline direction. Then underline direction. While in refraction, underline frequency, underline wavelength and speed. So that is that, so that you can take note of the parameters. The next one we are going into is diffraction. 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 You have something like this, like this, like this, like this, like this. Put one in the middle, like this. Alright, then you have something like this. Barrier. This is plane waves, then this is diffracted waves. Plane waves and diffracted waves. Sorry. So diffraction, this is the formation. This is the formation. This is the formation of circular. This is the formation of circular or spherical waves. This is the formation of circular or spherical waves by plane progressive waves. By plane progressive waves. Passing through a narrow opening, passing through a narrow opening, passing through a narrow opening, passing through a narrow opening or barrier, passing through a narrow opening or barrier. Full stop. passing through a narrow opening or barrier, full stop. It is also the bending of waves. It is also the bending of waves. It is also the bending of waves. Bending of waves round corners. Round corners. Round corners. Now let's digress a little bit. How many of you used to watch all this shark movie? Yes, Deep Blue Sea. So I want to paint a real life scenario to explain these diffracted waves. So assuming there were two couples, they went on an holiday in maybe Maldives or Malaysia or somewhere. They were on a yacht, so they were just flexing, flexing, and flexing, and flexing. Now taking champagne and enjoying the view. Normal vacation vibes. All of a sudden, the great white shark just came and sank the ship or the yacht. So the yacht was sinking. The shark was already inside the yacht. There will be small amount of water. Maybe they are trapped inside maybe a room in the lower deck. Hello, I'm explaining something. I want you guys to grab this. So they are trapped inside a room in the lower deck. Then the shark came, was banging the door. So now, if you in that kind of scenario, if you observe the water that will be inside where the couples are, you observe that the surface of the water will form something like this. How many of you can paint that kind of scenario? Have you watched a movie and seen something like that? There's water inside where they're trapped, and there's also water outside. Just like when a normal ship is sinking. So when the shark is banging the door, the door is locked tight. So now the wave that will come from the surface of the water outside will be plane. Then the one that will be formed inside will be spherical, will be round like this. To be round because the force that one is using to hit the door. So that's kind of scenario now, because the spherical wave will be formed at the corner of the door. You just see it on the surface forming around like this, So that is what diffraction. What is happening to that water wave is called what? Diffraction. Do you guys understand what I'm saying? These bros don't understand. The way you are looking at me. Yes. You understand what I'm saying? Alright. So that is diffraction. Now let's move to the next one. Interference or superposition. Make sure you put down this diagram for you to always remember diffraction. Once you remember this diagram, you know what diffraction is. It is the bending of waves around corners. Formation of spherical waves from plane progressive waves. That is diffraction. Why is your own wave going up like this? Going up like this? No, that's not how I drew it. One wave is traveling up. Alright, interference. 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 Put in brackets superposition. Interference. Put in brackets superposition. Superposition. When one wave is on top of another wave. When one wave is on top of another wave. When one wave is on top of another wave, comma, the waves are said to be superimposed. When one wave is on top of another wave, the wave are said to be superimposed. For those of you watching us live, like, share, comment, and also subscribe. So that is that. They are said to be superimposed. Full stop. As a result of their superposition, as a result of their superposition, as a result of their superposition, they tend to interfere with one another. As a result of their superposition, they tend to what? Interfere with one another. Tend to interfere with one another. Full stop. Or should I come again? As a result of their superposition, the two waves interfere with one another. Full stop. There are two types of interference. One, we have constructive interference, and two, we have destructive. So the constructive can also be called additive. Then this one's subtractive. So I said constructive or additive interference and destructive or subtractive interference. Now let's go with the first one, constructive interference. Constructive interference. Constructive interference. Constructive interference. When the two waves are in phase, when the two waves are in phase as in this phase, are in phase, when the two waves are in phase, comma, the crest of one of the wave, the crest of one of the wave intersects the crest of the other wave. The crest of one of the waves, those of you at the back that are putting your head down, raise your head up. Thank you. Sit properly. Yes. The crest of one of the wave intersects the crest of the other wave, and a new wave is formed, and a new wave is formed, and a new wave is formed, and a new wave is formed. A new wave is formed, having twice the amplitude of the former. This is what I'm talking about. Having twice the amplitude of the former. So we have something like this. The first wave to be like this. 1, 2, 3. Let's make it like this. Then the other one. Now this is the crest of the first one. The trough also intersects. The crest intersects, and the trough also intersects. So once they are added together, remember I said it is additive interference. So the new wave that will be formed will now have this one amplitude, assuming the amplitude of this one is 0.1 and the amplitude of this one is also 0.1. So we have something like this. The amplitude of this one will be what? 0.2. Because of what? Why? Why is the amplitude of this one 0.2? They are added together because of what? Superposition. Because they overlap each other. Are you getting this now? Sometimes you might have, most times you have more than one wave traveling together. Are you getting it now? So sometimes they overlap each other and and form a new. Are you getting it now? How many of you have watched Flash? I've watched Flash. I'll be Barry Allen. How did he used to pass through what? Now, how does that this thing? How is it possible? Because it vibrates to the point that he is in the same phase with what? With the wall. Are you getting it now? Before it can pass through. Without him being in phase with the wall, it cannot pass through. Are you getting it now? And when I mean the wall, I do not mean this wall. I do not mean this wall. I mean the particles that are inside the wall, the atomic particles. Are you getting it now? It is no more in the normal state you are. It will vibrate to the point that it is in the atomic state of the wall. So when they are now in the same phase, it can now move through it. Are you getting it now? So same thing is happening here. This one and this one are in phase. Are you getting it now? They are overlapping each other. If they don't overlap, they can't add to each other. Are you getting it now? So once they overlap, they add and form a new wave, which is having twice the amplitude of the former. Are we together? Is there any question? Any question? All right, so this is the new wave having twice the amplitude. So this is also the crest and the trough. Crest and the trough. Yeah, question time. Everybody stand up. Everybody stand up. One more round of question. No, it's not everybody. Those of you that were in class last week, stand up, stand up. Stand up now, stand up. Don't worry, we'll attend to them later. You stand up first. Rejoice. Hey. Madam, oh yeah. As of our boys come and there, didn't say. All right. Another question time. Yes, welcome back. Welcome back. What is trough? Don't sit down. What is trough? Trough. I gave you a definition of trough last week.
Hey.
See, all the bail you out, you are shining teeth. Bail him out.
It's the highest downward displacement of the
Sit down.
So I said one question.
Once you get your question, sit down now. Can you explain refraction? Ça va bien, merci. You don't know.
Refraction.
Yes. Say something. Yes, refraction. Wow, refraction is changing. Who taught you that? Me. Not me. Refraction. Oh, really? This is what I'm asking you. Refraction.
Okay.
Isale. Okay, Isale. It's different from refraction. It's different from refraction. I'm telling you refraction. There are two different phenomena. So you have to get it. It's not me I'm telling that one. You are reading it for me. Close the book. Close the book. Then I'll believe you. Me call. Yes, what is now refraction? Yes, explain that.
When you first before compression,
Why is like yeah? It's from refraction.
I don't know the final part.
So what do I explain that to be? The refraction. Yes, that one is real life example that I gave you. No. You are always reading from the book. No. It's reduced. Thank you. Sit. That's what I want to hear. The air pressure is a little below normal. That's what I told you yesterday. Sorry, last week. You read. Tell us compression. So you can sit down. Compression. When you tighten the spring.
When there's little or no
when there is no
when it's below normal.
Rejoice, what's the formula for frequency? Hmm? Yeah, I gave you frequencies F lambda. Eh? You said power of oscillation over time. Cancel down. Cancel down. What is wavefront?
What is it?
Wavefront.
Now, where do you
Me, I did not give you.
Wavefront.
Yes, like that.
No, that. Mm-hmm. In which a wave advances. Sit down with our bombo. Our bomb bomb. Our bombo. Sorry, our bombo. Like this. One of this all. Yes. Our bombo. The graph of wave is what against what? It's plotted as what against what?
Displacement against time.
Oh yeah, choose one of them. Sit down, just choose one of them. What do you mean, wicked? Now, brotherhood now. Okay, rejoice. How many complete wave do we have here? How many complete wave oscillation do we have here? Sit down. Just sit down. Sit down. Joko. Yes, you in red. What's the SI unit for frequency? Frequency. Spell it. Sit down. Now you finally. The question I have for you. At what angle does longitudinal wave travel? Yes. It's simple. It's simple. Wave at right angle. At what angle does longitudinal wave travel? I said one travel perpendicularly and the other parallel. And when you say parallel, is that angle 0? No. Thank you. 180 degrees. Straight line. Angle on a straight line is what? Aha.
Wait, I don't understand it. There's no
straight line, bro? Perpendicular is
Right, okay. I'm okay.
I see what it's night time.
Angle on a straight line is what? Okay.
Like that. Like this. That's how you mean today.
Alright, sit down.
So you just keep yourself on this.
So this waves, like they're coming like one and okay, so where is the source of vibration? Let's say the first parallel, like this.
Perpendicularly.
Okay, this perpendicular, this perpendicular, that's the graph. So that means parallel is Okay, yes,
All right, the other one. Okay, before we move to destructive interference, the part difference. Write this down. The part difference. The part difference. Part difference. PATH. The part difference between the wave. The part difference between the waves is an even multiple of pi. Is an even. Can put this down. The part difference between the waves is even multiple of pi. So this is the part difference. Change in L. And it is an even multiple of pi. T is an even multiple of pi. Destructive interference. Destructive. Another name for destructive interference is what? All right. Destructive interference. This occurs. Destructive interference. Destructive interference. This occurs when two waves. This occurs when two waves moves out of phase. This occurs when two waves move out of phase. Phase, as in this one, PHASE. Yes, they move out of phase, comma. The crest of the first wave, the crest of the first wave, the crest of the first wave intersects the trough of the other. Intersects the trough of the other. So it results in zero or no wave being formed. It results in zero or no wave being formed. It results in zero or no wave being formed. It results in zero or no wave being formed or produced. So you have something like this. You have something like this. Let me clean this second one. You have something like this. So this one, the crest intersects the what? The trough. And this one, the trough intersects the crest. Then this one, the crest intersects the trough, and the trough intersects the crest. So they cancel out. The what? They cancel out. Crest and trough, they are what? Opposite now. Minus times minus is what? Equals plus. Having. And plus is what? If you have plus 2, as answer. The same thing as what? 2. Plus same thing happens to this. This one cancel out this one. 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 So you have something like this, a flat or no wave being produced. Nothing will be there because the crests and troughs have all cancelled out. That is why it is called subtractive or destructive interference. Are we together? Any question? Any question? Any question? All right. So zero wave is being produced. Zero wave is being produced. So maximum destruction occurs. Put this down. Maximum destruction occurs. Maximum destruction occurs. Maximum destruction occurs when the waves are out of phase. Yes, maximum destruction occurs when the waves are out of phase by 180 degree. By 180 degree or pi. So assignment 1. Assignment 1. Give reason why longitudinal wave travels by. Now, someone say, is it 0 degree or 180 degree? If it is 0 degree, give reasons. If it is 180 degree, give reasons. Give reasons why longitudinal wave travels by 180 degree or 0 degree. Yes. Give reasons 180 or 0 degree. Since it travels in the same direction of the medium of its propagation, which is what? Parallel. Now, let us see reason why it is 180 or 0. That is assignment 1. So, okay, I'll give 2 later. Full stop. Let's continue. When the waves are out by 180 degree or pi. Full stop. The path difference. Yes, continuation of where we stop under destructive wave. The path difference between the waves, the path difference between the waves is an odd multiple of pi. The path difference between the waves, the path difference between the waves is an odd multiple of pi. Definitely you have something like this. Change in L is equals to where n equals 1, 3, 5, 7 and so. The last one, polarization. Polarization. This is an exclusive property. This is an exclusive property. Polarization. This is an exclusive property of transverse wave. This is an exclusive property of transverse wave. Full stop. Only transverse waves can be polarized. Can be polarized. Only transverse waves can be polarized either by reflection. Take note, this polarization we are going to discuss it better when we are already talking about optics. Sure you get. So you just need to know what type of wave possess this kind of character. Do you get that? That's for wave theory. But for light, you treat it properly as an exclusive property of light. Alright. So moving on, I say light waves can be polarized either by reflection at polarization angle, or by passing it through polarized plane, or by passing it through a polarized plane, or by passing it through a what? A polarized plane. I want you to take note of this. Note bene. All waves possess the first four characteristics. All waves possess the first four characteristics, but only transverse waves possess polarization. Only transverse waves possess polarization. Full stop. Yes, Ibiawi Gongolade. Ibiawi la shaking. Ade. How many of you are Yoruba? Are you Igbo or Hausa? Hausa. Hey. Africa. Yo. All right. Earlier on, I said we'll be discussing the wave equation. So this is the part where you pay more attention. Attention. Okay. Now we change the topic from characteristics of waves to so we are progressive or what? What's the other name? Hello? Progressive or traveling. Thank you. Progressive or traveling waves. Progressive or traveling waves. Progressive or traveling wave. And this is a form of what type of wave? Thank you, a form of transverse wave. I want you guys that are just joining us to catch up the next class. The previous class, watch it. It is on the YouTube channel. Watch it. Then you catch up the next class. You merge the informations. Then catch up the next class. All right. Moving on. A progressive. Wait. Progressive or traveling waves. A wave, a wave, a wave, a wave, a wave spreading out continuously. A wave spreading out continuously in its medium. A wave spreading out continuously in its medium. A wave spreading out continuously in its medium is said to be progressive. It's said to be what? Hello, I'm talking to people now. It's said to be what? Progressive. Thank you. It's said to be progressive. Full stop. It either travels along the positive x direction. Positive y direction. Wait. Let me see. Positive y direction. Wait. Okay, it either travels along the positive x direction. Positive x direction. It either travels along the positive x direction or the negative x direction. Or the negative x direction. This is what I mean. The wave can travel either like this. Hello. Either like this or it can travel like this. Hello, are you guys seeing this? Yes. I told you guys you need to pay more attention here. Hello, you need to pay more attention here. It can travel either along the what? Positive x direction or negative x direction. That can move to the back or move to the front. Are we together? All right. Moving on. We have something like this. Hello. From this point to this point, what do we have? Hello. From this point to this point, what do we have? From this point to this point, what do we have? Let me name it. Point A, from point A to point B. What do we have? Speak out now. one complete oscillation. And what does that denote? Yes. Talk now. Now look at this. I said between two successive crests. Within two successive crests, we have what? Between two successive crests, we have what? Is lambda having? Now, if you trace this to this point and also to this point, the distance between two successive crests is same as the distance between this point and this point. Are we together? From one crest to another crest, we have a complete cycle, right? Yes. Now, from point A to point B, we also have a complete, and that denotes that what? Between this point and this point, we also have lambda. Abi? Now, this part now to this part to this part, let's name it C and D. From point C to point D, what do we have there? Lambda over 2 having. And what shape is this part giving us? This point from C to D, what shape is it giving us? Triangle. Curve. Who is saying? Semicircle. Semicircle is a shape now. I'm asking what shape? Is what? Semicircle, Abby? Semicircle. What is the angle in a circle? Angle in a circle. 360, Abby. 360 degree. We say 170. 170 of all angles. 170. So angle in a circle is what? 360 degree, Abby. So in a semicircle, what do we have? 360 divided by 2. And this 180 degrees is also same thing as what? Is this lambda? Pi, Abby. Now, between from point A to B now, we have how many semicircles? 2 semicircles, Abby. And that will give us what? What angle? 360 degree, Abby. Which is also equals to what? 2 pi. Abby? Are we on the same page? Yes, sir. Now, if we have lambda to be also equals pi, we want to get the face angle. The face angle. The face angle, for the face angle, we can say x is equals to phi. What shape is it? What do I call this now? Phi. 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 Hello. Did you understand how I got lambda is equals to 2 pi? Yes, sir. Abby? Yes, sir. Now we're looking for the face angle. If we should cross multiply, what do we have? We can say lambda phi is equals to what? X is 2 pi, Abby, or let's say 2 pi x, Abby. 2 pi x. Now divide both sides by what? We are looking for, remember, we are looking for this one. This phi, which is the face angle, having divide both side by lambda. So we have our phi, which is the face angle, to be equal to 2 pi x over lambda. Now, asterisk this one. This is the introduction to the wave equation. I'm just bringing bread from my pocket. Okay. So I hope we understood this now. Any question? Any question before we move on? Once we move on, no looking back. Any question? Any question? Hello, madam. What's your name? Bolu. Madam Bolu, do you understand? Rejoice, what's the name of your friend? Amina. Paula, Shawelo. Aha. So hope you understand this. Alright. Okay. Did I know you? What's your name? So put down this question. Okay, once you are done, can put down this question. A progressive wave has wavelength of 50 centimeter. A progressive wave has wavelength of 50 centimeter. Full stop. Calculate the phase difference. Calculate the phase difference. Calculate the phase difference. Calculate the phase difference between 2 points. Calculate the phase difference between 2 points 20 centimeter apart. Calculate the phase difference between 2 points 20 centimeter apart. Now, what are the parameters given? Yes, let's highlight them. Wavelength 50 centimeter. Then what else? Distance between 2 points 20 centimeter apart. Now, since the both of them are in centimeter, let's just work with what? Centimeter. Now, what did they ask us to look for? Phase difference. Now, whenever your answer is still in pi, in terms of pi, it is the phase difference. But whenever you convert the pi back to degree, is what? To give you phase angle. Are you getting it now? All right. So we have our phi to be equal to what? 2 pi x over lambda, having, and this is what? 2 pi times 20 over what? 50, having, police key thief, having. So phi is equal to what? 4 pi over 5. Let's say 4 over 5 pi. Now the part difference is what? 4 over 5, which is what? What's 4 over 5 in decimal? What do we have? 0.8. So we can say this is 0.8 pi. Now to get it in degrees, the phase angle, now is the part difference. The phase difference is what? The part difference of phase difference is what? 0.8. Are you getting it now? Degrees now, we have 4 over 5 times 180, having 5 here 1, 5 here what? 36, having 36 times 4. What do we have? 144. Thank you. 72, 72, having. So that is 144 degrees. That is the phase angle. Is there any question? Is there any question? So the phase difference that they asked for is what? 0.8, having. Then the phase angle is what? 144. Is there any question? Is there any question? I'll give you question. Questions, Japa. All right. Now this is the major part. Can I rub this off? Take your time. The displacement of a progressive wave. Under subtopic, the displacement of a progressive wave. The displacement of a progressive wave. The displacement of a progressive wave. The displacement y, the displacement y, the displacement y of a progressive wave, the displacement y of a progressive wave, the displacement y of a progressive wave is given by the displacement y of a progressive wave is given by y is equals a sine omega t plus or minus phi. Equation 1. The displacement y whenever you are You guys have done resolution of vectors. Abby? Abby? Hey, whenever you are resolving along x plane, what do you use? Is it cos or sine? Or what about y? Sine. So you have y is equals to what? A sine omega t plus or minus phi. Now all these ones that I see here is the what? Is the angle. Are you getting it now? Then why the A is the what? Is the amplitude. Omega here is the angular velocity. T is your time. Y phi is your what? Phase what? Thank you. Now we have omega to be equals 2 pi f and phi to be equals to what? What's the formula we got for phi?
2 pi x over lambda.
2 pi x over lambda. Having?
Yes.
Now if we should give me that phone. Bank me. Give me. For 19. Give it to me. Let me pass it. I never knew I would change my phone this year. Oh, good God. I shall tell Tony DP. Alright. So we have y is equals to what? A sine what?
2 pi f.
2 pi
F.
f plus or minus, okay, 2 pi ft plus or minus what?
2 pi x over lambda.
2 pi x over lambda. Are we together? Hello? Are we together? We are not together. Now, what's the formula for angular velocity is what? 2 pi x. Are you getting it now? Then for our phase angle, we got what? 2 pi x over lambda. Abi? From the previous calculation, we got our phi to be equal to what? 2 pi x over lambda. It's like you guys are already confused. The formula for angular velocity is what? 2 pi f. Then phi is what? 2 pi x over lambda. Abi? Stop writing when I'm explaining so that you get what I'm saying. So now, if you input value for omega here, you get this 2 pi ft. Then for phi, you get what? 2 pi x over lambda. So now, what is common here?
Pi.
2 pi, thank you. A sine what? 2 pi into bracket what? Ft plus or minus what? X over lambda. Now recall that V is equal to what? F lambda. Make F the subject. F is equal to what? Divide side by lambda. V is equal to what? V over lambda. F is equal to V over what? Hello? F is equal to what? V over lambda. Now, if we input V over lambda here, we have what? Y is equal to what? A sine what? 2 pi F. V over lambda. Or let's say Vt over lambda plus or minus what? X over lambda. Are you seeing what I'm doing? Are we together? Are we moving at the same speed?
Yes, sir.
Towards the same direction?
Yes, sir.
And towards the same goal? Hey, yes, sir, is reducing by the way. I hope we're on the same page.
Yes, sir.
All right. So we have y to be equals to what? A sine. What is common here? Lambda. A sine 2 pi over lambda. Open bracket what? Vt plus or minus x. Now can someone tell me why the minus is there? Why are we putting plus or minus? Thank you. Remember, before we started this, I gave you something. I said wave can travel towards the positive side of the x and also the negative side of the x. Abby? So that's why we're having plus or minus. Do you get that now? So you can put down all of this. You can start this one, 2, this one, 3, this one. No, leave this one out of it. This one not too important. This one, 4. So these are the equations we'll be using. These are wave equations we'll be using to solve questions. Is the derivation hard?
No, sir.
All right. So sometimes, they can say you should look for the wave number. So this one, sometimes they can write it as y is equals a sine k into bracket vt plus or minus x. So this k now is the wave number, which is a constant. So you can say k equals to 2 pi over lambda, which is wave number. Please take note of this one. Take note. So sometimes are we together? If I say are we together, I say always together. Are we together? Always together. Do you people need bobo or visual milk? Mr. Fruit. Okay. How visual milk will work? Okay. We'll talk to Mr. SOS. Children or come out to you. Vlog.
Yeah.
Alright. So the above equations, are you guys done? Are you guys done?
Yes.
Are we all done? Rejoice. Hey, this is what I look like. I hope you understood what we have done. Okay. We will know if you understand or not. The above equation can be used in determining the above equations can be used in determining the one. After that, they put semicolon. The above equation can be used in determining the one amplitude, 2 frequency. The above equation can be used in determining the 1 amplitude, 2 frequency, 3 wavelength, 4 speed of wave. Now let's take this beautiful question. Shall we? Shall we?
Yes, what
Hmm?
you said you are going to
These are the equations now. I said the above equation can be used to look for. That's all this equation. They can be used to look for the amplitude. No, that's no question. That's not the question. Now this is the question. Write this down. The displacement. The displacement. The displacement of a progressive wave is given by y is equal to 0.38 sine 100 pi t minus pi x. Yes, the displacement of a progressive wave is given by this. It's given by this. Where y is in centimeter, comma, where y is in centimeter, comma, x and t are in meter and seconds respectively. X and t are in meter and seconds respectively. Full stop. Determine the one. Determine the one amplitude. Determine the one amplitude. Two frequency. Three wavelength. And four speed of wave. How do we go about this? Yes. Which of the equations are we using? Which of the equations are we using? Yes? Equation. Is it equation 3? Equation 4. Is it equation 4? Equation 2. Thank you. You compare and contrast. See this. We have A here. Sine. Pi t. Pi and t is present. Pi and t. Pi and x is what? Present. They are more in what? In common. Are you getting it now? So, with that being said, let me rub this off. Hello, is there any question before we proceed? Is there any question? Hello, is there any question? People are talking. Here you want to come and teach us. He's telling you something. You two are now telling him something. You people come and tell the class something. So, what was the first question? Amplitude, thank you. So from here now, we can just say our amplitude is what? Then, what else? The second one is what? Frequency. 2. We have 2 pi ft. 2 pi ft is equal to what? 100 pi t. These equations are what? Are the same. So this one is equal to this one. Are you getting it now? So you just compare and contrast the parameters. So 2 here 1, 2 here 50. Pi cancel, t cancel. So f is equal to what? 50 what? Thank you, 50 and 50 t call. 50 coffee. Alright, the third one. What are we looking for? Wavelength. Lambda. Lambda. So this one is carrying lambda. We can equate to this, Abby.
Yes, sir.
So we have minus 2 pi x. Hey, look at what I'm doing. Oh, I brought it out with the what? With the sign. Are you getting it now? Because this one is carrying minus, so I brought it out with the sign. So equate it to what? Minus pi x, Abby. Minus cancel minus, positive. Pi cancel pi, x cancel x. So we have what?
2.
We have 2 over lambda is equals 1. Abby? Because if up and down everything cancel each other, we will still be left with 1. So if we cross multiply, so we have 2 is equals lambda, therefore lambda is equals 2 meters. Then what else? Which other parameters? Speed. So speed wave or wave speed is what? Given as v is equals what? V is equals what? What is formula for speed of wave?
V equals to F lambda.
Stand up, please. Stand up. What is formula for speed of wave? F over. You are coming. You have not been in this class. Been distracted, and I was watching you. Now, the people that are distracting you are not distracted. V is equals to what?
F lambda.
F lambda. So we have V is equals, what is F?
Times
50 times 2. So V is equals to what?
100 meters per second.
100 meters per second. Is there any question? Any question? Put that down and you have your seat. Hello. Pull down this question, one beautiful question. Okay, swallow me. Swallow me. A radio station assignment. Yes, assignment. A radio station assignment. A radio station. A radio station. A radio station broadcasts. A radio station broadcasts. A radio station broadcasts. A radio station broadcasts at a frequency of 600 kilohertz. A radio station broadcasts at a frequency of 600 kilohertz. A radio station broadcasts at a frequency of 600 kilohertz with the speed of light. With the speed of light. With the speed of light. Full stop. Calculate. Calculate the wavelength of the radio wave. 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 Another sweet question. The equation, number 2, the equation the equation y is equals 5 sine 2 bracket 3x minus 4. The equation y is equals 5 sine 2 bracket 3x minus 4. Close brackets, comma. Where y is in millimeters. Where y is in millimeters. Where y is in millimeters, comma. X is in meters. X is in meters. And T is in seconds. And T is in seconds, comma. Represents a wave motion. Represents a wave motion. That's all these parameters represent a wave motion. Full stop. Determine the frequency. You are with the amplitude, so you just write 5 for me. 1, frequency. 2, wave period.
It's wavelength.
Wave period. And 3, speed of wave. And 3, speed of the wave. 3, speed of the wave. Speed of the wave. Speed of the wave. So this is where we call it a day, and thanks for watching.
Next class.
Please like, share, and subscribe.
Next class. Next class, how do you come a question?
What are you paying?
So someone should call Mr. SOS. Don't go yet, everybody sit down, sit down, sit down. Sit down, sit down. Sit down. Yes, call SOS. So we might have questions from the comment section. So
I also am not shouting.
I have seen you laugh.
I'll see you. La Coco. I have seen you, La Coco. Only two people are working on Daniela. Why? Enough. Let's go.
Class enough.
yes, saying like, share, and comment. So leave your questions in the comment sections. Next week we'll catch you up on the same channel. So bye. In the absence of no question.
I'll see you, La Coco.
Who is La Coco?